Okay, now I will go through the exemplar problems in the class 12 physics chapter 1 electric charges and fields. Okay, before going through the problems, I will show you some information. Okay, general information. See, first thing is this units used. Okay, electric field, volt per meter or Newton per coulomb. Okay, these unit you should not memorize just like that. You have to see what is electric field means. Electric field means force per unit charge. Okay, so here if you say force per unit charge, force is Newton per unit charge is Coulomb. So Newton per Coulomb or volt per meter. Okay, like that you have to remember. You have to remember the definition of what is electric field, dipole moment, all those things. Okay, electric flux, voltmeter or Newton meter square per Coulomb. Okay, this other unit. Okay, dipole moment is Coulomb meter. Linear charge density lambda. Okay, coulomb per meter. Okay, surface charge density. Okay, this is sigma, coulomb per meter square. Okay, volume charge density, this is pronounced as rho, rho, coulomb per meter cube. Okay, so now let us say you want to find out the what is the unit for this Coulomb's formula. Okay, force, electric force equal to K, Q1 Q2 by R square. So now the K, that is a constant Newton meter square per charge square. Q1 charge, that is also Coulomb, Q2 charge, that is also Coulomb, distance in meters. Okay, so this R square meter square. Okay, so now this meter square will cancel, this Coulomb square, these two Coulomb charge will cancel. So now the net unit is Newton. So like that you have to find out the unit. Okay, the other unit is the other thing, important thing is the how to find the total charge. If they are given the charge distribution, let's say linear charge density. Okay, so in a sphere, okay, that is you have to find out the volume charge density into this is the volume charge density into the volume of the sphere 4 by 3 pi r cube. Okay, this is RH rho. Then for the, let us the surface charge density, like say in case of hollow spherical cylinder, sigma surface charge density into this 4 pi r square is the area of that cylinder. This is linear charge density. So the total charge is linear charge density into length. Okay, this is like for example of a thin wire. Okay, okay. Now question number one, two positive charges, okay, is given. Fixed along the y-axis. Okay, the y-axis they are given. Exert a net force on the positive x direction. Charge Q1 fixed on the x-axis. Okay, okay. If a positive charge Q is added at this, the force on Q1, okay, which direction it will come. So the force is a vector quantity. Okay, mm, the net force is the vector sum of all the forces. Okay, see here, this is a negative charge and this is a positive charge. Why I am saying negative charge? Because they are saying the resultant vectors on the x direction. So only if there is attraction between this charge and this charge, then the force will be on the x direction. So we assume this is a negative charge. Okay, this is the resultant vector. Okay, now if you put a charge here, this charge will be in the x direction only. Okay. Hmm. Resultant charge. Okay, there is a sample in the book also. Okay, you can go through this, how they given this resultant force direction, the vector coordinate. So increase along the positive x direction. Okay. A point positive charge is brought near to the isolated conducting sphere. Isolated conducting sphere. The electric field is best described by C, and there is a positive charge. The field lines will go away from the charge, and the what is in conducting sphere. So here positive means there will be negative charges induced here, will be a positive charge here. So the field lines are going away from this induced positive charges. Here also positive charges. Okay, so this one is the correct one. Electric flux through the surface. The gaseous law, as per the gaseous law, 34. See, gas is a Q enclosed by epsilon naught. Okay, so the Q enclosed here is same in all the figures. Okay, because the charge enclosed is same in all the figures. So the same in all the figures. So electric flux will be same in all the figures. Flux is directly proportional to the enclosed charge. That is directly proportional means if you increase the charge, then electric flux will increase as per this formula. Five charges are placed as per this fixed at their position as shown, and there is a Gaussian surface also. The Gauss law. So the Q enclosed is the charges enclosed within this Gaussian surface only. Okay, Q enclosed here this right side of this equation, and this E here is due to the all the charges. Okay, so this is the LHS of the above equation will have a contribution from all the charges electric field. Okay, while Q on the or a right hand side will have the contribution from enclosed, that is Q and Q2 only. These enclosed charges only. Okay, Q2 and Q4, that is the enclosed charge here. Okay, Q2 and Q4. So this right Q enclosed will be from Q2 and Q4 only. Enclosed charges 34. That is I already showed you. Figure 1.5 is this is the electric field. The field lines and which an electric dipole B is placed as shown. Which of the following statements are correct? See, looking at the electric field, this is not a uniform electric field. See here, you see in this area, if you take this area, here more lines, here same area, here will be less lines because see the lines are going is not straight. Okay, so this is a non-uniform electric field. So the dipole will experience a force towards left because the field is somewhere here charged. So the more strength on the left side than the right side. The strength of the electric field is more on the left side. The number of files in the given area so is more. So okay. So 31. See here, this is given for the uniform electric field only. Okay, the net force on the dipole is zero for uniform electric field. But that is given is not a uniform, it's a non-uniform electric field. Okay, here this field lines is a non-uniform. That is why towards left. Point charge Q is placed at a distance of d from the isolated conducting sphere. Okay, the field at point P on the other side of the plane is that is so here this is the charge and the positive charge and induce a negative charge. The other side there will be a positive charge. Okay, so positive lines will go away from the flame. Okay, field lines are because this is a positive charge going away from the flame. Okay, lines are away from the positive charge and perpendicular to the plane. A hemisphere is uniformly charged. The electric field at a point and the diameter away from the center is directed perpendicular to the diameter because this is positively charged. It is go field will be going away from the hemisphere and perpendicular to the diameter. This integration of ds equal to 0 over a surface, that means q enclosed will be 0, that is Gauss law. The number of flux lines entering into the surface must be equal to the number of flux lines leaving it. Okay, this one correct. All charges must necessarily be outside the surface because here we are saying 0, that means that there is no charge inside. Electric field at a point is always continuous. No, continuous if there is a no charge at this point. Okay, if there is a charge, then there will be what the direction of the charge directed towards that charge. Discontinuous if there is a charge at that point. See, electric field, you can make out these things from this only, from the diagram only. See here, if there is a charge, that is why these field lines will come, then again going from here. If there is no charge, it will be continuous. Okay. There are only one type of charge in universe. Then this delta is equal to if the charge is outside of this Gaussian surface, and the key equal if there is a magnitude of charge is inside the surface. Consider the region inside. There are several types of charges. Okay, more than one type of charge. That means dipole. But total charge is 0. At points outside the region, various types of charges means dipole. Outside the region, the dominant electric is inversely proportional to the distance square law, or where r is the distance from the origin of the region. The work done to move the charged particle along the closed path and that regions will be 0. Okay, this is what given. We have to read these details. Refer to the arrangement of this and the Gaussian surface of radius r. Okay, this is the Gaussian surface with the q at the center. Then the total flux through is q enclosed by epsilon naught. The q enclosed here is the q plus minus 2q. The q enclosed is minus q. Okay, this is correct. Field on the surface of the sphere equal. Okay, this field includes field lines actually as per that formula includes the charges inside and outside the surface. Okay, so the field lines will include this also. This is wrong. Flux to the surface of the sphere due to okay, yeah, the flux is only for include charges only within the Gaussian surface. Field on the surface of the sphere is due to minus v everywhere. No, the distance will be different at various points. A positive charge q is uniformly distributed along the circular ring of radius r. A small charge q is at the center of the ring. Then these are the q 0. Okay, this you can go through it or understand it. An arbitrary surface encloses a dipole. What is the electric flux through that surface? The dipole net charge is 0. So Q enclosed is 0 and flux is 0. A metallic spherical shell having the radius R, radius, a metallic spherical shell having radius R1 and outer radius of R2. A charge is Q is placed at the center of the sphere. What will be the surface charge density on the inner surface and the outer surface? Okay, 15. Okay, this is like this only. Okay, they are asking what is the charge outside, inner and outside. Okay, so this is radius is r1 square. This is r1. This is r2. Okay, so charge divided by the area is the charge density. Okay, minus q inside the surface. So minus q divided by 4 pi r1 square, and the outer surface is this. The dimensions of an atom or the order on this, there must be a large electric field between the protons and electron. Why then is the electrostatic inside the conductor is 0? 16. Okay, the electric fields bind the atom to the neutral entity. Fields are caused by the excess charges only, excess charges. So there can be no excess charge on the inner surface of an isolated conductor. No excess charge on the inner surface of the isolated conductor. Okay, the total charge enclosed by surface is 0. Does it imply that electric field everywhere on the surface is 0? No, this is does not mean that. Conversely, if the electric field everywhere on the surface is 0, this imply that, okay, yeah, answer. No. First one is no. Okay, the total charge enclosed by surface zero means it is imply that electric field also zero. No, that does not mean is electric field also zero. But this is true. That is electric field everywhere on the surface zero. It is imply that net charge is yes. This is true. Okay. Okay, question number 18. Sketch the electric field lines for the uniformly charged hollow cylinder. Okay, hollow cylinder. Shown in the figure. Okay, this is the top view and this is the side view. Okay, because this is positively charged field lines are going away from the cylinder. What will be the total flux through the cube? Okay, this is slightly complex things. I will show you the answer. You can go through the book. Okay, these are the answers for the all the things. A paisa coin is made of aluminum MgLi and weighs okay. Is square shape okay. It's electrically neutral and contains the equal amounts of positive negative charges. Treating the paisa coins made up of aluminum, only aluminum, find the magnitude equal number of positive negative charges. What conclusion do you from this? Windows 20. Okay, here the molar mass. This is the Avogadro number. Okay, one molar mass has this many atoms. So each atom has how many charges? That is proton and neutrons. Positive charges. Okay, charge on the proton into number of charges. Okay, um, this is an enormous amount of charge. Thus, we see that. Ordinary neutral atom matter contains enormous amount of the charges. Okay, positive negative charges. See, this is the aluminum's atomic weight. Okay, atomic number and atomic weight. Atomic number 13, atomic weight is. Consider the coin of the example. Okay, it is electrically neutral and contains equal amount of positive and negative charges. Okay, of magnitude. Suppose that these equal charges were concentrated on 2 point charges. Okay, points separated by this distance. For first 1 centimeter, and then 100 meter, then three this many radius. Find the force on each point charges of the three cases. What do you conclude from this? Okay, force that is Coulomb's law. 1 by 4 pi epsilon naught is the K. Okay, so you substitute for these charges and the constant, then you will get this force. Then using this, because the force is directly proportional to the distance, they are using this force, they are computing the force for the other distance. Okay, the conclusion. See, force is inversely proportional to the distance. Okay, so inversely, this is a denominator is coming. Okay, conclusion. When separated as point charges, these charges exert an enormous force. It is not easy to disturb the electrical neutrality. 1.1 here represent the crystal unit of this, represented by the open circle. Okay, what is the net electric field of the C net onto the CL due to the all CL? Due to symmetry, this electric field at the center will be zero. Okay, zero beyond the symmetry. And for the second case, suppose that an atom the center is missing. What is the net force on the CL atom due to the sum and say, remaining atoms? Okay, that you have to compute this charge by distance square. Okay, this is how they are finding the distance. Okay, and this is the net force, and directed from A to CL. Two charges given magnitude are placed on the x-axis separated by the distance. What should be the charge key placed such that where we have to place this key such that it will not experience any force. Okay, so one positive negative charges will attract each other, positive positive charges will repel each other, so the force between these two is repel, whereas these two is attractive force. Okay, we have to keep this in such a way that this force will cancel out each other. Okay, they are given like this. Okay, so using this formula, finally they arrived at the distance. This force, the attractive force equal to the repelling force. So here you have to remember that when substituting charges, they are taking only the magnitude. Okay, not the sign, because this formula is having the modulus. Okay, modulus means you should discard the sign while computing the magnitude. 2q into q, 2q square, remaining 2q into 3q only. They are neglecting the sign there. 1.1 shows the electric field lines surrounding 3 point charges. So, which charge is positive means field lines will going away from the charge, and this is also going away, and this also is going away. This is positive and this positive. Which charge has the largest magnitude? Okay, there are more lines within the given area, so this is the largest magnitude. In which region or regions of the picture could the electric field be zero? Identify again near A. Here only we are having break. So the electric field in here A only. Show the answer also. 24. Okay, near A. There is no neutral point between the positive and the negative charge. So the neutral may exist between the two like charges. Um, Here we see that neutral point exists between the charges A and okay. Yeah. Five charges are placed on the what will be the electric field at O, the center, what will be okay. These things they are given. So the answer under 25. Okay, they are given this first is 0 due to symmetry and these other things they are given. Okay, due to symmetry the for the second case and the third case. Because when we remove this charge will be equal to the other charges because center due to symmetry will be 0. So this is the charge, net charge. What will be the electric field? That is net electric field at O from one of the corners is removed. So this is the net electric field. Net electric field. Okay. Now it's 25. Same as this. Okay, this for the long answer. This you can go through this gaseous law, Coulomb's law, and you can see the answers here. 26. Okay, answers for all the things are given. You can go through the answers using that formula. And okay, this is the inside the cell, then the outside the cell. So these three formulas are given. You can go through it. For all these things also answers are given. There is a simple organic motion problems also is there. This is important. You can go through it. Okay. Okay. You can also go through these solved problems in the NCERT textbook.